Hello everyone, this is Prashanth. Let's continue with the last lecture. So here I am dealing with the controlling of IoT devices, controlling hardware devices. So in the last class, just we have completed controlling of servo motor and DC motor. So these are the two hardware devices just we discussed about these things in the last class. What are the specifications, what are the components to make the connections on the breadboard, what are the microcontroller code to dump the microcontroller, like that. We have different applications based on that servo motor and DC motor we discussed in the last class. Now we move entering into the another hardware controlling part in IoT, motion detector sensors and wireless Bluetooth sensors, some level sensors. So these all are the sensors, motion detector, wireless Bluetooth sensors, level sensors. So just to so before that, first we have to know the some objectives the student should be able to learn. The outcomes and objectives of motion detector sensors, wireless Bluetooth sensors, level sensors and USB sensors, like all tie back to the core principles of IoT are objectives. So here the comes under the objectives of this particular topic. Data collection, connectivity and communication. So data collection is nothing but gathering of data. So the every IoT device, the main aim of the IoT device is just it is gathering some information or collection of data. A core principle of IoT is gathering data from the physical world. These sensors allow serve the objective of collecting specific data points, motion, Bluetooth signals, field levels or environmental readings. So these are the about data collection and connectivity and communication. So here another key principle is establishing connections between the devices and the internet. The while USB sensors are wired, the other rely on wireless protocol to transmit their collected data. So that is the under objectives, data collection and connectivity and communication. So next, just we outcomes we have some more. Here the improved efficiency and automation, enhanced decision making, remote and control. So the improved efficiency and automation. So compulsory automation is nothing but compulsory. It automatically it can detect the device and is there any loss of information, that may information pass to the particular destination part, the information is going to end, like that. Some alerts it can send. So that is the automatically the process will going on inside the device. Based on that, the efficiency also will be improved. By collecting and transmitting data, these sensors can contribute to automating the task and optimizing the process. Just for instance, the motion sensors can trigger lights or adjust thermostat, while level sensors can signal for material refill. So the refill is nothing but the information just is going to end. For example, this pen. The pen, for example, this is a pen, IoT, just it is IoT device. So when the ink inside the ink is going to end, so automatically the information sent to the particular destination part. So the ink is going to end, like that, just you can refill the data. So that is the level sensor. That just it can maintain the level of the ink up to the lowest mark. So that is the by specifications of different motion sensors, like thermostat, like that. Next, enhanced decision making. So automatically it can take the decision based on the situation. The data collected by these sensors can provide valuable insights. Business can use this information or improve inventory management, optimize resource allocation, or gain a better understanding of user behavior. So this is the enhanced decision making outcome. Second one, the third one, remote monitoring and control. Monitoring and control, just you can manage the entire system and controlling the system also. IoT principles enables remote monitoring and control. These sensors allow for real-time data access, enabling adjustments or interventions from a distance. So this is the third outcomes, that is remote monitoring and control of the IoT device. So these objectives and outcomes all contribute to broader goals of IoT, creating a network of intelligent devices that interact with the physical world and generate valuable data for various applications. So these are the outcomes. Improved efficiency and automation, like that. Motion detector sensors, like just we have the current topic is motion detector sensor. So from first onwards, controlling devices, connecting LED, buzzer, and high switching device using transistor, switching transistor like, and relays. Just now we completed in the last lecture, switching transistor, relays, DC motor, like that. So here next one, motion detection sensor. So these are the some controlling hardware part. In the realm of IoT, Internet of Things, the motion detector sensor can act as the eyes of your devices. So them enabling them to prevent movement, perceive movement within their environments. These sensors plays a crucial role in various applications based on the foresting, security, automation, and enhanced user experience. Here a deeper dive into their working principles, types, and how they integrate into IoT projects. So this is the first one. Next, understanding motion detection. What the involvement of motion detection sensor in to develop the IoT project. Motion detection sensors don't have directly see the movement. The function by detection changes in specific physical quantities that occur when objectives are moving. Here are some common operating principles of motion detector sensors. Passive infrared sensor, that is PIR. So it is very important sensor in order to gather the information. Passive infrared sensors. These ubiquitous sensors detect infrared radiation or heat emitted from objects. When a warm object like a person or animal moves across sensor field of view, the radiation pattern changes, triggering the sensor. They are ideal for indoor application. So that is the first sensor, that is infrared sensors, PIR sensor, and microwave sensors, and ultrasonic sensor, and video motion detector sensors under understanding of motion detection. So here one of the sensor, that is a passive infrared sensor, that is important. The next second one, microwave sensors, ultrasonic sensors, and video motion detector sensors also available. Microwave sensors, unlike the PIR sensor, these emit and detect high frequency microwave radiation. Any movement with the detection zone disrupt the microwave field, triggering and the sensors. So their ability to penetrate walls to some extent makes them suitable for outdoor applications. So this is the about microwave sensors. And ultrasonic sensor. So here for ultrasonic sensor, they work by emitting high frequency sound waves and detecting their echoes reflected from the object. So the movement within the detection zone changes the echo pattern, triggering and sensors. They are relatively inexpensive but can be affected by temperature and humidity variations. So this is about the ultrasonic sensors. And video motion detection. This method leverages cameras to capture video footage, analyze the frame by frame differences to detect the motion of the object. It offers the advantage of providing additional information like object size or movement direction, but requires more processing power compared to other sensor of the data. So these are the remaining three sensors: micro sensors, ultrasonic sensors, and video motion detection center sensor. So depends on our requirement, just we may use whatever the sensors are required, like microwave, ultrasonic, video detection sensor. Next, choosing the right sensor to develop the IoT project here. The first one, selecting the most suitable motion detector sensor for to develop the IoT project for several, depends on the several factors. Environment, for environment, just we use PIR sensor, just we discussed in the last slide only. PIR sensors excel indoors, while microwave sensors perform better outdoor or while needed to penetrate walls or objects. So this is the, so based on the application only, just we use different sensors like PIR sensor or micro sensors to for better understanding. And detection range, for detection range, consider the required coverage area for your application. So based on the coverage of area of the network, just we may use detection range. And sensitivity, balance the desired level of sensitivity to avoid false alarm while ensuring efficient detection or movement. That is consider sensitivity. And power consumption, the power consumption for battery powered applications, consider sensors with low power consumption like PIR sensors. That is the first one. The last one, cost. In terms of cost, the PIR sensors are generally the most affordable option. So it is very cost, nearly 10 to 100 to 200 rupees for one sensor. Based on the applications, based on the ability to do the activity, we are choosing right sensor to develop the IoT projects. And next, integrating with microcontrollers here. This is the connection method varies, depends on the sensor type. The PIR sensors often use a simple digital output, while ultrasonic sensors might require additional signal condition circuits. Microcontrollers can be programmed to read sensor data, apply algorithms to filter noise and confirm motion detection. Then trigger actions based on the detection motion, such as turning on lights, sending alerts, or recording the video. Next, these are the some integration with microcontroller for different activities based on the requirement. The next one, applications of IoT here, smart motion detection sensors are serve a multitude of purpose in IoT. In different applications we have in smart homes, so security system, building automation, automatic doors, smart pet devices, smart retail. So in home automation system we have different specification, triggering lights upon detecting motion for improved security, convenience, and energy saving devices. And in terms of security system, detecting unauthorized entry or triggering alarms for enhanced home security. So that is under security system. And building automation, in building automation, turning off lights or appliances in unused rooms for energy efficiency. Automatic doors, opening doors as people approaches for hands-free access. The last pet, smart pet devices, monitoring pet activity or tracking their movements also, but that is the important one. And retail, in terms of retail, tracking customer movements pattern to optimize store layout or product placement. So these are the some applications in IoT based on that motion detector sensor. Next one, these are the some learning resources for this activity. Just you can explore online resources for type of motion sensor with Arduino. Example, PIR sensor with Arduino, like that. Just PIR sensor with Arduino. Just you can type, or you will find tutorial explaining specific sensor types, connection methods, code example, and project ideas. Whatever the not only with this, just it can explore the data to develop the new IoT device or trending IoT device also. Starter kits for microcontroller often include motion detector sensors, allowing you to experiment with motion detection in a practical setting. So that is the second one. And by understanding the motion detector sensor, just conclusion part, a summary, detection sensor and their integration with microcontrollers. Just you can import your IoT projects to react to their surroundings, creating intelligent and interactive system to enhance our lives in various ways. So this is the importance of motion detector sensor. With that, just we are developing some more real-time projects based on the requirement. Next one, the last one, wireless Bluetooth sensors. So here Bluetooth is nothing but just it is a wireless protocol within the range of 0 to 8 meters only. It's the maximum device for Bluetooth is 7 devices connected at a time. So this is the maximum devices. This is the range of Bluetooth. So here wireless Bluetooth sensors in real time of Internet of Things. The wireless Bluetooth sensors plays a vital role to creating, connecting and intelligent systems. They offer a convenient and efficient way to collect data from sensors without the halls of wires, simplifying development and scalability in various IoT applications. Just you can assume in your mind. So understanding the things here, these sensors integrate Bluetooth low energy technology for wireless communication. The first thing is Bluetooth low energy technology, and Bluetooth low energy is a power efficient version of Bluetooth designed specifically for data transfer in IoT device. So that is the second one. The last one, it offers a good balance between the range, that is typically up to 100 meters, and power consumption, make it suitable for battery powered sensors. So these are the just the things to understanding of the wireless Bluetooth sensors. And benefits of using Bluetooth wireless Bluetooth sensors. So here the first one is easy deployment. So here no need of complex wiring, simplifying installation and maintenance. For example, nowadays just we are using wireless Bluetooth also for just listening the songs, just to speak with some other person through the phone. So just you can on that open the door, just to open the door, just automatically it will connect to the mobile phone without any installation or installation process or complex wiring, whatever the thing, just no need. Just within fraction of seconds, just it automatically will connect it to the mobile for the headphones. So that is the easy deployment. The second one is scalability. Adding or removing sensors becomes easier as they do not require any physical connections. To adding or removing, just no need to do any physical work. Like that is the under scalability. And cost effective. Under the cost effective, eliminates wiring cost and simplifies installation, potentially reducing overall project cost. So that is the cost effective. And low power consumption. So here Bluetooth low power energy technology extends battery life also for sensor nodes, crucial for battery powered applications. That is the low power consumption. And real time data to enables the continuous data collection and monitoring for remote sensors, that is the in real time data. So these are the some benefits of using wireless Bluetooth sensors. Easy development, scalability, like that. So here the types of wireless Bluetooth sensors. Here just we have 4 types of Bluetooth sensors: environmental sensor, motion detector sensor, wearable sensors, and asset tracking sensor. So in terms of environmental sensor, these sensors measure various experimental parameters like environmental itself. Just you can record temperature, humidity, pressure, or air quality. Just these are the input parameters for environment. Just when the environment, the word is came in, just it is just we are going to discuss about environment. Just the compulsory we need to know the parameters like temperature, humidity, pressure, air quality, air pollution, how much air pollution will be done, like that, just the input parameters. And motion detectors, in motion detectors detect movement using technologies like passive infrared sensor or accelerometer sensors. And wearable sensors, they integrated into wearables like smartwatches or fitness trackers to monitor heart rate, activity levels, and other psychological data. That is the wearable sensors. Next, asset tracking sensor, used to track the location and status of objects or equipment in real time. So that is the asset tracking sensor. That is the types, one type of Bluetooth wire sensor, asset tracking sensor. So these are the four important types of wireless Bluetooth sensors. Environmental sensor, just it can track the parameters of environment like humidity, temperature, pressure, air quality. And motion detector sensor by using PIR, passive infrared or accelerometer sensor. And wearable sensor, asset tracking sensor. Applications of wireless Bluetooth sensors in IoT, smart homes, smart buildings, industrial applications, precision agriculture, inventory management, and healthcare. So these are the important applications with the help of wireless Bluetooth sensors in IoT. Smart homes, smart buildings, industrial automation, precision agriculture, inventory management, and healthcare. Smart home is nothing but monitor temperature, humidity, and occupancy for improved comfort and energy efficiency in the home. Smart buildings, to track the assessment, performance, optimize energy usage, and automate building management task. So that is the second one. And industrial automation, just in order to monitor the life cycle of the missions which is available in the industry, like monitor the production lines, detect equipment failures, optimize the industrial process. So that is the comes under industrial automation. Next, to precision agriculture. In agriculture also, just we use track the soil moisture, temperature, other factors are informed irrigation and crop management. Irrigation system also, just we may use compulsory IoT devices also. Inventory management, so monitor stock levels and optimize inventory control in warehouse and retail store. So that is the inventory management. The last one, healthcare, medical department, wireless health monitoring our patients using wearable sensor for vital signs and activity tracking. So these are the some real-time applications of wireless Bluetooth sensors in IoT. Consideration for using wireless Bluetooth sensors here: range, security, battery life. These are the three major consideration for using Bluetooth wireless sensor. Range, security, and battery life. Range is nothing but Bluetooth low power energy has a limited range compared to other wireless technologies. Just I already know it is just 8 meters only. Up to the 8 meters, it can connect to the devices. Consider the required communication distance for your application. Next, to improve security, implement proper security measures to protect sensor data from unauthorized access or manipulation. The last one, battery life. Battery life depends on sensor usage and communication frequency. Choose sensors with suitable battery capabilities or implement low power operating condition. These are the learning resources: Bluetooth low energy with Arduino, or Bluetooth sensor applications in IoT. Just you will find tutorial explaining Bluetooth enabled low power energy technology, sensor types, connection methods, code example, like that. So these are the learning resources of the sector. Level sensors. These are the level sensors to detect the height or volume of a substance in container. This substance can be liquid or solid or even the sludge. Types of level sensors: float switches. Here, ultrasonic level sensors. Here, two types of level sensors we have: float switches and ultrasonic level sensors. Connective level sensors. Here, the third type of level sensor. The last one, pressure level sensors also we have. To pressure is proportional to the fill level. Remaining continue with the next lecture. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.